All right. The next speaker actually met his wife at a conference just like this one. Now he's here to talk about AI agents. Please welcome Max.
Thank you. Right. Hey, everyone. I'm going to be talking about AI agents today. And as you are all probably aware, there's a lot of hype going on around AI agents these days. A lot of people are calling 2025 the year of AI agents. There's a lot of like agentic products out there. But in this talk, I'm specifically going to focus on how we as developers can start making use of agents to solve our own problems. A few words about me. My name is Max. I'm a web developer from Switzerland, but like most recently, I've only been like doing AI development. I'm a previous author and entrepreneur. And if you want to follow me, I'm Gfeller on X, and yeah, I'll obviously love to connect with as many of you as possible. So you can also find me on LinkedIn and everywhere else, basically. So I'm an engineer at this startup called Sutro, and at Sutro we are using AI agents, and we are building the next generation of AI native no-code builders. It's actually pretty exciting. It's very cool, and we are hiring right now. So if you're looking for a new role, please let me know. Before we get started, let's start with the definition. What are AI agents? So there's a lot of kind of like competing definitions out there. I would say it's like not always entirely clear what's an AI agent, what's not. And so I've picked this distinction that Anthropic made in their guide to build effective agents. So they are making the distinction between basically workflows, which are systems where LLMs and tools are orchestrated through predefined code paths, and agents, on the other hand, which are systems where LLMs dynamically direct their own processes and tool usage, maintaining control over how they accomplish tasks. So it's basically, we have like agents which are like completely autonomous, basically, and then we have like the workflows where we as developers basically give a bit more structure into like how the whole thing is going to work. As I mentioned earlier, there's like a lot of agentic products out there, and if we are looking at the more like technical products, or like products that are geared towards developer or help us develop, then we can kind of like start from the left side, where we have like the products that are meant for more like non-technical people, where we have like Lovable and Bolt, which allow basically non-technical people to write code. And then in the middle we have it's kind of interesting. We have Devin. Devin is called like the first AI software engineer. And I think they are kind of like marketing right now as like an intern software engineer that can just go on itself and kind of contribute to your code and everything. And then basically on the right side, we have more of those like professional tools that are meant for developers like us and just help us write code. Now, all of those new products, they have like sparked this new wave or this new trend of what Andre Karpathy called wipe coding. And wipe coding is like this new thing where you talk to the LLM, you let it write the code for you, you don't even look at the code, and you just go based on wipes. Like, if it doesn't work, then just tell it, it doesn't work, fix it, fix it, fix it. And Yes, as you can imagine, probably there's a few problems that come from that, right? And here's really just a few of those. There's like hundreds, thousands more of those, right? Like one, guys, I'm under attack. Ever since I started to share how I built my SaaS using Cursor, random things are happening. Maxed out usage on API keys, people bypassing the subscription, creating random shit on DB, and all of those things basically, right? And this one guy who just like hacked all the most popular, lovable products and so on. And yes, Devin, on the other hand, is also not really delivering on its promise just yet. This is a recent article actually from the beginning of the year. Tool touted as the first AI software engineer is bad at its jobs, testers claim. And it nailed just 15% of the tasks that were assigned to it. So we're not really there just yet. We're not just going to be replaced. But what's the issue with those tools? I think when it comes to agents, it's just that experts are always going to be like way more efficient than generalists. And generalists is like, that's what all those other products are. They let you write like any code. And yeah, so today in this talk, I'm going to be focusing how we can like develop expert agents that help on like very specific issues that we are having. There are a ton of agent frameworks out there now, and I think there are new ones released like at least weekly, if not daily. And it's not super easy to like choose one. This is a nice Google table which Harrison Chase, the author of LangGraph and LangChain, made recently, just comparing like the biggest agent frameworks out there right now. And so on the left side, we have LangGraph. LangGraph is probably the most used right now, I think. Then we have the Agents SDK from OpenAI. We have the Google's Agent Developer Kit. We have LangChain, AutoGen from Microsoft, CrewAI, and then there's like a lot more. I've personally only worked with LangGraph and LangChain and CrewAI, and I think like LangGraph is probably the one that lets you do the most things. It's also the one that probably has the worst documentation. It's like really difficult to like get started doing something. There's like a really high learning curve to it. And so my favorite framework right now is actually CrewAI, which is like, it has this wonderful documentation, makes it super easy. It's like really easy to get started with, but it also has like this huge ecosystem, and yeah, you can do like a lot of advanced things as well. So in this talk, I'm going to be showing you how to build those agents using CrewAI, but I think like you can take the ideas and use any framework of your choosing, basically. So one of the key ideas in CrewAI is this role, goal, backstory framework. And so this is basically on what like, this is just like to get the LLM to behave like in a very specific role. So the role could be like a technical writer or something. The goal is like something very clearly defined that it should reach. And the backstory is something like, well, you graduated from Harvard, you were the top of your class. Since then, you worked 10 years as like an expert lawyer or whatever. And all of this basically helps to like, it's kind of like a role-playing thing, right? You get the LLM to role-play, and they are actually like really good at that. So, and then of course there's just like various ways in how you can combine multiple agents into crews, what they call it. And so usually you would have something like one or more tasks which are then being handled by one or more agents who each have like access to various tools. And like each of those agents has like their specific role, their specific goal, everything, right? And then there's like various ways in how those agents can work together. It can be like a very iterative thing where you have like the agent one go first for the first task and then the second agent for the second task. But there can also be like delegation and like all sorts of things. It's like really cool. But by the end, you have a task output. This can be like either a text, it can write to a file, it can be a structured output, anything. Sorry. So I'm going to show you the first example. So I'm going to be showing you a bit of code. I'm not doing any live coding, but I'm showing you a bit of code. I'm doing live demoing. And by the end of it all, I'm going to show you a link to a GitHub repo where all the examples are. All right, so the first example, keeping user documentation up to date. Right, so what's the problem that we want to solve? The problem is we have some sort of application and we have a user-facing documentation, and if we make changes to the application, then someone always has to go and make updates to the documentation, right? Otherwise, it's going to be out of date. I think that's something that we probably all know, like out-of-date documentation. It's just not fun. So solution to that could be, well, we could have an AI agent which makes sure that the documentation is up to date after every change that we make. And how exactly could that look like? Well, for example, this could look like that it's like a GitHub action or something that is running like inside every pull request, then goes through the diff and analyzes basically all the changes, and then goes through all the markdown files to see if they're up to date or if they need updating, and also if necessary, just go ahead, make new screenshots, and then just commit the necessary changes. Would you agree that this would be useful to have? Nice. All right, this could actually be like, at least in our example, this can be like a super simple crew. So we have the task input, which is going to contain the diff of the changes that we made. Then we have the first agent, which the doc updater. It has access to the tools to read the documentation and to write the files again. And then there's another agent which is tasked with updating the screenshots if necessary. So it would basically analyze that based on those changes, is there going to be like a change in the UI as well? And if yes, then just like take the necessary screenshots. And then in the end, the result is we're going to have like the updated docs. That's it. All right. In CrewAI, this is how we can write our agents. So first we start with the doc updater agent. Its role is a technical writer of like user documentation. Its goal is update the user documentation to reflect the latest changes in the code base. A backstory is you are a technical writer with a deep understanding of the code base and the user needs. You are able to write clear and concise documentation that is easy to understand. And it has access to tools. Those tools are really just provided from CrewAI, so it's like really easy to use. Basically, one tool that just allows it to read this one doc file. In this example, it's really all just in one file. And the file writer tool to write this anew if it had to make changes. And then each agent can have like a different LLM assigned to it, which it uses. And in this case, I'm just going to be using GPT-4o, which is fast and cheap. And we also need to create the task, so the docs updater task. So a task is really what we give to the agent. So in here it says, update the user documentation to reflect the latest changes in the code base. Here's the diff of the changes. Then we can use like a placeholder variable. And then use the tools provided to read and update the user documentation. And the expected output is, in this case, really just like a summary of the changes that it made. Doesn't really matter that much. It's something that the next agent will see. And we assign this to the docs updater agent, and that's it, basically. So then we have our next agent, which is tasked with updating the screenshots. And I see I didn't update the roll goal backstory here, but it has the take screenshot tool, and that's all it needs, basically. And then for that, I have a task as well. Take a new screenshot of the updated UI if something changed in the UI. Use the provided tool to capture the screenshot. And it assigns this task to the screenshot updater agent. And so all that is left to do now is we need to assemble a crew, this docs updater crew, where we assign the agents that we just defined, the tasks, and then there's like, we're just using a sequential process, so basically do the first task, then do the next task. There are other models as well. And then in the end, just kick it off, pass in the inputs, in this case, just the diff that we get from Git, and then let it run. I'm quickly going to show you how that looks like. So basically, we have our small example app here. So it's really just a to-do app. Doesn't do too much. You can add a new to-do. You can remove to-dos. And here we have the documentation. Obviously, it's just an example. In your use case, probably a lot bigger than just that. But in here, basically, we write how this app can be used. For example, we say, let me make this a bit bigger. We say, like, type your task in the input box, click the Add button, and then we have a screenshot here, and that's it, right? Now, let me make a very simple change. All right, so this is the app. I'm just going to say here, this is the button. I'm just going to say we want to make this a bit more verbose. So I'll say it should be called Add Task. And so in here, we can see it's Add Task. Now the documentation is out of date because it says Add. So let me just run this doc updater. I'm going to run this. And then, as you can see here, we get all the verbose output. Of course, we could put this into like a GitHub action instead of running it locally. And as you saw here, it had to take a screenshot as well. And now everything is completed. Crew execution is completed. So let's check it out. Let's see. Here it says Add Task button. This is nice. And here it still says Add. But if I refresh, oh, yes, the screenshot was updated as well. And here it says Add Task. So this was super easy, right? And this can obviously be scaled if you have like a complex application, if you need login whatsoever. All of that is doable. Or if you're showing like something that, if you have like a model or just like a few to-dos in here already. I was using just a play right now to make a screenshot of this URL, but we could use something like a browser use just to make it a bit more, like actually describe what it should do, take a screenshot of that, update all the documentation, and that's it. All right, let me get back into the presentation. Okay, so the next example that I want to show is keeping our code base sane with the custom linting rules. So, problem is, in our code base, we have a lot of developers working on it, and it's just hard maintaining best practices, right? Like someone in a pull request might say, hey, maybe don't do it like that, but in that case, it would just be good if we could like create a linting rule or something for that. But it's actually not that super easy to very quickly add a new linting rule because like those things can be complex. So, solution would be create custom linting rules for all non-obvious coding guidelines. And how? Well, first of all, we need to have like I'm a front-end boy, so I'm just gonna talk about ESLint. So I have ESLint set up in a project, enable custom rules. Then we'll have some sort of AI agent that can generate and install new rules on the fly. And then it would be even cooler if we could integrate this into an IDE somehow so that we can make it more accessible. Now, I have tried in the past like a lot to develop linting rules using AI. And sometimes it's great, sometimes not so much. Like sometimes it just fails. So for this example, instead of just using a crew, I want to use a workflow. And the workflow is, well, first of all, we have the description of the new rule provided by the user. Then the first task is just going to be like prepare test cases. Like prepare 3 test cases where it should fail and prepare 3 test cases where it should not fail. Then we let the AI implement the rule. And then we have what we call like a router or like a decision point, basically, where we run the test cases. If they fail, we go back 1 or 2 steps. And if it succeeds, then we kind of like can complete the whole thing, write the rule, and that's it, basically. And so how could this look like? So this is an agent and a task, just task with creating examples. And so what we're using here is something called a structured output. And when we're using Python, we can use pydantic models. So we have the example set with the positive and negative examples. We even have a model validator where you can check that it's exactly 3 each. And then we have the code examples model with the examples. And for simplicity, I also added like the rule name in here, just so I don't have to add another step. But basically come up with the rule name in kebab case. Then we have the agent, so the ESLint test case creator, which is going to be using GPT-4o. And then we have the task, like a kind of like an extensive task description, which is not super important right here, and the expected output. And we can say the output pydantic. So we are using this pydantic model as the structured output. So basically forcing the LLM to answer in this specific schema, in this specific model. And we assign the task to the agent, and that's the first step. Now the next step would be to come up with the linting rule, right? Once again, I'm going to be using a pydantic model for that. The only reason is that if you say, well, just output like the source code. If you do that without using structured outputs, oftentimes we either have backticks in there, you have like additional text in there whatsoever, so I'm just going to be using a structured output. And then we have the agent, turn requirements into a fully functional rule with ID custom rule. And this is a veteran JavaScript tooling engineer specialized in ESLint plugins, so must be good. And we're using the O4 mini reasoning model for that, just because it's like a bit better at reasoning about like the effects of the rule. And then we have the rule task, where we specify the output model and the agent, and that's it. So Now we just have to put all of this together. We have this workflow, which has kind of like this internal state as well. And then there we have like those different steps. So the first one is generate examples, and we're really just using the agents that we built before. We're running them, and then we're persisting the examples and the rule name in the internal flow state. The next step would be the implement rule. So yeah, also that is just like this agent that we kick off. We let it do its thing. And then next up would be like the validate and save. And as you can see, this is a router, meaning that it's basically based on some kind of logic that we are defining. It will reroute to another step. So that's either like the finish step, the generate example set, or the implement rule set, based on what happens. And so basically we try to run it, and then we say like if expected error got none, then it's probably a bad example case. So we go back all the way to the beginning. And if it, like we are also saving like the validation attempts, and we're limiting it to 5. So if it didn't pass the test, it will just go back and try to rewrite the rule. And then in the end, it will either fail or it will write a file, and that's it. All right, I will also show you how this works. So, basically what I'm doing here is I'm adding a new rule, disallow console.log, a super simple rule. And once again, I'm starting it through the command line. So it came up with the examples. Now it's at the step to implement the rule. Because it's a reasoning model, it takes like a little bit longer to do that. But it should soon be done. And then the next step would be just going through all the examples, through all the like test cases, test them, and in the end, it's hopefully going to work because it's a super simple rule. Yes, there we go. It made this rule. It actually failed validation first, and then it retried. And then it completed it successfully, which is interesting because it's a very simple rule. OK, so if we take a look now, it's made this new rule. And yeah, it's not too difficult. And so this works. So this I could easily just import into my project and then start linting my own files. I would say this is probably, like, starting it through the command line is probably not too accessible. So I will show you how we can make this a bit better. And so that's where I'm going to be talking about MCP, or the Model Context Protocol. Now, MCP is basically this new standard that was developed by Anthropic in, I think, November last year. And basically, it's just like LLMs already had the ability to use tools, right? And so MCP is really just kind of like coming up with this standard of making those tools a bit like reusable. And so any host, like any MCP client, it could be like Claude Desktop, it could be, I think, ChatGPT soon, Cursor, other AI clients whatsoever, they can start their own MCP servers. They have this specific protocol that they communicate with them with, and then basically those just expose like additional functionalities, like additional tools, but also like give access to specific resources. So you can do all kinds of wild things with that. I saw, for example, someone built like an MCP server for like a 3D modeling tool or something, and you can just use it from Cursor, and it's super cool. Now, the cool thing is that this was literally May 9th, so like 4 days ago. He's the author of CrewAI, and so they just made this change that literally every crew can now just be exported as an MCP server, but on the same time can also like consume MCP servers, so it's pretty cool. And then basically we can just add those MCP servers to like Cursor or something, have them run there, and we can use them just inside of the tool, which is pretty cool. And I'm going to be showing this to you very quickly. All right. There we go. So in here, I should have access to the tools. And as you can see, someone wrote this comment, and I would say this is unacceptable. Please use the tool to create a new linting rule that disallows profanities in comments. And so I hope it works now. Yes, so it's trying to call the MCP tool. And you can see it passed in the description, create a lint rule that disallows the use of profanities. And it already gives examples. That's a good time for photos. And yeah, so now it's this workflow is running again, and I really hope that by the end of it, it could add. Yes, so it implemented the rule. Now we have to include this in our ESLint config, and I can just let Cursor do that. Please do that. And so it will find my ESLint config, it reads it, and then it will import this new rule. It makes all the changes. No profanity in comments, and as you can see now, it's red, and it says, avoid using profane language in comments. And the fun thing is, if I go to check that out, then it really has like a blacklist of words which OpenAI came up with, which is pretty nice. Yeah. Yes, so I would say this can be like, just because it's so accessible, right? You can just like, whenever there's any kind of discussion, you just make a new rule and that's it. Okay. I have one more example and that's it then. So the next example is going to be about app administration. And it's basically now from the other side. Like the problem is, we have like a super cool app. There's a ton of people using it. We don't really have that much insights into what our users are doing, and we don't really have a way yet to like trigger admin actions like reset password or something. And also like building one of those backends can be a lot of work, right? Now, the solution to that could also be that instead of building a new application for that, it could just be, well, we're just making an MCP server with all of those tools, with all of those resources, basically, and then expose it, like use it from an existing chat client. That's it. So much easier, right? And so how? Well, we create a custom MCP server. We implement just like a lot of tools, and we use any chat app like Cloud Desktop or anything else, and just use it from there. And to make this happen, there's a lot of ways to like create your own MCP servers. So like the official MCP repo on GitHub. I think they have like a lot of starters for like all programming languages, basically. For Python, I think this fast MCP is kind of like the best way to go. Fast MCP v1 was what they after that used for the official MCP template for like the official in the official MCP repo, and this one is even better. So we're going to be using fast MCP to create a new MCP server. In this case, really just the admin backend. You can provide additional instructions which the LLM then sees. So this server provides functionality for the admin backend, but we can like provide a lot of like additional instructions here as well. And basically in MCP, we know like resources and tools. And it's basically the same thing. It's like, to me, it's kind of weird that those are different things. But so there's like, we could have like a user profile, for example, that we expose as a resource, which takes the user ID, and then we can like easily implement this, like fetch this from the database, or I don't know, read it from an Excel sheet or whatever you use for your database needs these days. So this is a resource. This is a tool. This could be like something like a password reset, send a password reset email. And yeah, I think like if you just have to implement only the functionality of that, don't have to care at all about like the UI, the functionality, any of that, I mean, that's going to be so much easier for us, right? So for this example, I've been building this for our app Starik that Valentina and I built together, and she talked a bit just before. So it's just a platform where our users can order custom books. And I started building just like this small MCP server to help us with administration of that. So let me just show you that. That being said, there's honestly not, like it doesn't have that much functionality just yet, but I can ask it how many open orders do we have right now? And then it will use this tool to query books to order, and we can run this. So this client that I'm using is called Chatwise. It's pretty cool because you can use it with any kind of LLM provider. I'm just really using OpenRouter and Grok here, but you could use literally like any AI model out there. You can also use it for local models, which is pretty cool. And so yes, it used this tool. We can inspect like the result. It's basically like all the open book orders, and then it says, there are currently 33 open orders. And then, of course, we can also say something like, please give me a list of the English titles of the first 10 book orders. And I think it will just reuse the, yes, it will just reuse the output from the previous MCP call. And that's pretty cool, right? Because those titles were in Hungarian. I didn't understand them. And so because I have this context here, I can do like all sorts of things with it. And it's going to be like really cool if you combine this with other kinds of MCP servers. So for example, you could add an MCP server that lets you create new charts and diagrams, right? And then you could say, hey, like draw me a chart of like the user signups over the last 30 days, something like that. Now I haven't implemented this functionality just yet, so it won't work. But there's like there's so many possibilities that you can do, and yeah, for someone just administrating this app, this has all it needs. We don't need like this fancy dashboard whatsoever, and we saved ourselves a ton of time. All right, those were my examples. So let's do a very quick recap on what we covered today. So first of all, we started off with this definition of AI agents and a few examples of AI agent products, but also like their shortcomings. I showed you an overview of a few agent frameworks out there. I gave you a quick introduction to CrewAI. I showed you how we can create agents that support us in our daily work. Gave you a quick intro to MCP, which enables just a lot more use cases for us. And then, yes, how to use MCP clients like Chatways to administer our app. And yes, as promised, all of those examples are in this GitHub repo. The last one, the MCP app administration, is really just like a template for you to use and to fill out with your own functionality. All right. Do you have any questions?
Thank you, Max.
Thank you.
Yeah, thank you for that. One thing you didn't talk about it in this talk, but something that I haven't quite sorted this out in my own workflow is I've got, I don't know how many subscriptions. I've got the web interface. I've got, potentially cursor, and which is not exactly the same thing. How are you managing all of your access to these different LLMs?
How do I manage access of like?
Yeah, Open Router I think is one thing you mentioned, and I think that
yes.
one is specific. So like right now I have payments going to
okay,
everybody,
yeah.
and I'm yet to like figure out, all right, well, I need to like structure this how exactly. And if you're thinking about how to create your tools this way, how would you suggest paying for all of these LLMs?
Yes, that's actually a very good question, and it's a real pain point. I would say I've been using Open Router more and more. Like in the past, we've been using OpenAI directly, and we just ran into so many issues. You get like rate limited. Even if you have like, you can have like $1,000 in like tokens there, and it will still rate limit you. So it doesn't make sense, right? And Open Router basically is only like minimally cheaper, more expensive. So you won't realize it. And you have access to literally all the models out there, and you only need to pay like this one platform, and that's it. So I can really recommend Open Router.
Yeah, I wonder, are you using, so you mentioned local model. So do you use local models, and if you do, how do you combine them with everything else? Like Crew has specific features that lets you combine them easy?
That's also a very good question. How am I using local models? So with CrewAI, you can easily integrate into something like Ollama, which is running locally. Well, my issue is that I just really have this underpowered MacBook, so I cannot really run the big smart models. So for anything useful, really, I cannot use it that much. If I had like a Mac Mini or something, Mac Studio, whatever, I would try to like run local models as well. But yes, in general, like the cool thing about CrewAI is because you are assembling those crews, you have those different agents. Like a pattern that I very often fall into is that like in the beginning, I have like a super smart reasoning agent that comes up with some kind of outline that informs the rest of the process basically. And all of the other agents don't need to be like so smart. because they have like a lot of the guidance from this like initial outline or something, and in there you could use like local models or just cheaper cloud versions as well.
You can use like Olama, like just for the start, and then the Olama can pick one on top, like to be used like if to pay less. For example, I want less transaction. I can start with Olama and then sending another to trigger another one with Olama. Let's say.
That's possible. Yes. A pattern that I'm often using is that when I'm starting to like implement new agents or something, then I will just use like the best option out there, like the smartest models, and then just like after time try to reduce costs a bit, and so see like what other kinds of models can I use which still have like the same effect but cost way less or are faster even maybe. And a lot of the times, like if you have the necessary hardware, that could also mean just running it yourself, but it really depends on your use case, and those cloud models are usually not that expensive. Yeah, DeepSeek, for example, is like really cheap to run online as well.
So I have a question regarding, like, we have to take into consideration that when we run something as an input to the LLM, we have to take the input window, the size of the context. It's going to affect afterwards the performance of the prediction or whatever output the LLM is going to give. So for example, if we have a really large code base and the documentation is pretty large, if it's going to keep, like with the MCP or the agent that we have developed, are we going to run into issues if we do this updating of the documentation when it has to run through the documentation? It's going to be divided by batches to avoid these issues.
Yes, probably. We would probably run into issues at some point, right? I mean, those newer models, they have like huge context sizes, so I don't think it's impossible. It's just going to take forever and it's going to be expensive. So I would really recommend, like, so this was a super simplified example, right? So what you would rather do is basically kind of like skim through the documents one by one, see in which you have to make changes, but don't do everything at once. Yeah. Or basically use something like just a search, or maybe you know like which part of the app refers to which part of the documentation, right? There's a lot of options to optimize this.
Regarding the MCP protocol, there were some issues with it regarding security. So have you also had a look at that?
I'm not an expert on that, to be honest. But yes, so I heard that there are some issues, and just in general, I would say like MCP is not like I don't think it's like super well designed or anything. It doesn't really make sense in a lot of the cases. It's weird that you have to run like your own servers locally. Although now there's the remote MCPs, which make this a bit easier, but still I don't think it's like the best designed protocol ever, but it's just, well, it's a standard that we can use, and yeah.
Do you know for MCP, is there a distinction between get and post sort of things? Like I know you had to say, yes, go ahead and run the query, but if it's just a query, maybe go automatically, but you could mark something as destructive. Is there anything like that in MCP of like,
that's a good question.
Always ask or go ahead, who cares?
So that depends on the client, actually. There are clients which I think you can do you can set the confirmation on a tool basis. And then with resources, I could imagine that you probably don't need to confirm it. Yeah, so resources are for reading, but only in certain cases, like something like a search or something, that wouldn't be a resource, that would be a tool. So I think it's a bit weird. And even like a resource, it's still like, it's basically the same thing as a tool, right? It's like fetching like a specific user by ID. So why they made the distinction, I'm not exactly sure. but maybe like this confirmation, that could be part of it, of course.
So as I kind of worked through Crew a bit, it was like, how do you inject a human into, I would assume these things grow, but as you kind of pointed out, maybe the better path is to turn it into small MCPs and functions. How far have you gone with that? Like, do you keep these things nice and small, or like, what are some patterns that you've found, I guess, growing more functionality and growing these agents?
Yes, that's a very good question. It's really just kind of like how to model those things so they make the most sense. So at Stark, we have kind of a like complex and long-running process to like produce books, which is kind of cool. But it only does like this specific thing. It just produces the book. It doesn't do like the whole thing of where we then wait for the user to confirm and then send the order or anything. I would say those would be like different steps, different crews, different workflows whatsoever. But what you said, or what you mentioned earlier, is actually a good point about like a human in the loop. And so there's, I think like CrewAI also has like a lot of options to basically in a long-running process, if there is like in just one step where a user has to like confirm something, there's tools for that, and there's also, I think there's now completely new startups that do something like this. So yeah, definitely interesting.
All right, I think that's all our time for questions. Thank you so much, Max.
Thank you very much. Thank you.